Okay, now I want to process this to make the spectra look nice to print up. So our processing, I have like an order that's really good to follow. I have it here on this sheet, and I'll show you in other places too. You want to start off in the base level, like we just did, right, of nuts. And then you hit A2 to bring over the FID, which we did. And then we're going to hit double click to get into the zoom subroutine. We're going to drag an area of the spectrum we want to print. And then we're going to enter to get out of zoom. And then we're going to add notes to it, like your name and description, get out of there. And then we're going to integrate and we're going to print. Oh, so let me show you all the steps there. Okay, so first off, I want to zoom. Double click, I'm in the zoom subroutine, see the ZO. I'm going to drag over about, I like to go a little bit wider than my most downfield, a little wider than my most upfield signal. I right click, and now I got it all on screen here, and I can like adjust the height of it. I don't want anything off scale, that looks pretty good. And then I hit enter to get out of the zoom subroutine. See, I'm in the zoom subroutine. So if I hit enter, base level again. Okay, now I want to add a text box. So do you know the command to enter a text box? Anyone? Anyone know the command? No? Did somebody say, no, you don't know it? That's good. Yeah, no. That's right. The command is no. Yeah, so if you're here, that's kind of a funny joke. So the command for write a little text box is N-O. When you do that, it'll show you you're in enter notes, but it's not obvious how to enter a note yet. What you have to do at this point is hit the letter A to enter a note. So you hit A, and then a box will pop up and you can start typing in what you have. So what do we have here? I have 95% ethyl acetate and 5% TMS. And I ran this, mark. I always want you to put your name, the sample, and also I want you to put the date. 10/8/2020. Okay, once you got your text box, then you click OK. And you move that to where you want it. Just click grab it. I'll put it up here. All right, so now I'm still in the enter notes subroutine. It's important that you get out of this before you move on. If you go on to another subroutine while you're in one subroutine, it'll drive you nuts. That's why they call it nuts. So don't let nuts drive you nuts. You have to make sure that you enter your notes, NOA, NO to get you in, A to add the note, NOA, type what you want, enter to get out. Then we're going to integrate. And how do we integrate? ID. So here it is. This is the cool part. So you type the command ID. So the letter I, you see it there? The letter I, the letter D, and an integration curve pops up. Isn't this cool? It's why is it still red? Did I get out of notes? Hold on. I'm going to enter a couple times. Okay. I might not have left notes. I talked about it, but didn't do it. All right. I just hit enter a bunch of times to make sure I'm in the base level again. And I am. And now I'm going to hit ID again. So ID. Okay, there's my integral. And I don't have a red box around the text box. That's good. All right. So what's happening here is this line represents, it's saying that there's 0 area under the curve here. And then when this part of the quartet, the one part of the quartet comes up, it rises because it's counting that area. It integrated the area under the curve. And then this one, it rose a third. Like, remember, it rose about 3 times as much. Because remember the Pascal's triangle, quartets are areas are 1 to 3 to 3 to 1. Okay, so I got that, and then the triplets here, and then the singlets there, and the triplets there, and then the TMS at the end. Okay, so how am I going to get integral values for this? What you're going to do is you're going to bring your cursor, see my cursor, to the side of one peak. I usually go to the left side. You click once and a red line shows up. You click one more time and a green line shows up. See that green? And now I can move my cursor away, that green's still there. So I do 2 clicks on one side, and then I move over to the other side of the signal, and I click one more time, and it chops up everything from the outside of this. Okay, so I've got that one's area taken care of. Now I'm gonna come over to my singlet. So I'm gonna click once, red, twice green, and then I'm gonna come to the right side of it, click once more, and look at that, it chopped out the area around that one. I'm gonna do the triplet. I'm gonna go once, red, twice green, one more, got it. So I've integrated these, and if you remember, this should be a 3 hydrogen singlet, this should be a 3 hydrogen triplet. Don't they look about the same area in terms of their integration, the height of the integral proportional to the area? And then this should be a 2 hydrogen quartet. So now I can set a value for any of these integrals. This one, this one, this one. Oh, why didn't I integrate TMS? Because that's just our standard to set to 0. It's not part of our molecule, so I don't need to integrate that. So back to this one here. I know this should be a 2 hydrogen quartet because I predicted it for our molecule. So what I do is I click once and get this red vertical cursor. I make sure it's within the integral curve here, and while it's in there, I go to the keyboard and I type the letter V. When I do that, this box pops up and it asks me, what do I want to set this particular integral to? I want to set it to the 2 hydrogens, so I hit number 2, and then I just click OK, and now it's my reference. This is 2, and relative to this signal's area being called 2, this one is 3.02, and that one's 3.10. Really close, right? These are what we wanted. We wanted a 2 to 3 to 3 ratio. And then at this point, we just print it. And to print, when you're in this software here, the NUTS software, and you're doing proton NMR, you're in the integration subroutine, you just hit the letter P. So let's see how it comes up. This is our Epson printer. This is the first print of the year. It might not come up well. Sometimes the ink cartridges kind of need to wake up after a break. Now we'll take a carbon NMR. So we are currently in the H1 setting, but we want to be in the carbon setting. So how do we get over there? Let me double check. Are you on screen right now? You are. Good. How do we get to the carbon NMR? We just type the command. And this is AII PNMR. We type the command. Watch it come out here. NU nucleus space C13. And then nothing happens until I hit enter. Now it's the carbon 13 settings. It's set to do 12 scans. It's 15 megahertz. Okay, let's do it. How would you guess we tell it to go collect that free induction decay data? Hopefully you're guessing ZG, 0 go. And we do it again, yep. Same as proton NMR. Type Z, G, and then enter. It's going to ask you to name it. We're going with the default name as always, so I hit enter a second time, and it's starting to pulse the radio waves for carbon NMR. For carbon NMR, carbon 12 is the most abundant isotope. It's not NMR active, so we need to find the carbon 13s. So instead of just doing a single pulse like we did for proton, we're going to do 12. So it's done 2 of the 12 scans, 3 of the 12 scans. And I'll show you later, we can tell it to do more scans if we want. Okay, so while we're waiting, we can look back at our predictions. Remember? We were looking for a carbon about 25 parts per million, the carbonyl 175, maybe 55 for the alpha to oxygen, 15 for that one. All right, our proton NMR printed. Oh, our carbon's almost done. Proton came out a little janky. I'm gonna clean the printer heads. All right, we're at 12 scans, 11 and 12 scans, and 12 scans. So now I'm gonna click OK to collect that data. It's telling me it's done. All right, so it's done. So what do I have to do? I have to go over to NUTS. And to bring it into NUTS, I like to get back to the base level first before I bring over the carbon NMR. What I'll do is I'll just hit enter, and it'll bring me back to the base level. Next up, I'll bring over the carbon scan. So the command to bring it over, it's not the same as hydrogen NMR. It's not A2. You have to instead hold the control key and then type the F3 key. Control F3. And we did use the default name, so we just say open, and it'll ask us some other questions. It's asking us for a line broadening value. We're going to use always the same thing, 0.5. And that's just some processing of the software. And then we hit OK, and look at that. It's looking pretty good. It's a little out of phase. See how it kind of has this negative aspect of the peaks? That happens. If we re-shim, it might go away. But what I wanted to see was 4 carbon signals, and I do. Look at this. I was hoping to get carbonyl. Oh, I did the wrong one. I was hoping to get a carbonyl carbon about 175. That looks like it. A alpha to oxygen about 55. There it is. And then alpha to carbonyl and a alkyl. These could be switched. I'm not sure. It looks like we are seeing the TMS. You don't always see it. I put a fair amount this time, so I'm seeing it. But make sure don't adjust the TMS when you see it on the carbon NMR. Because when you do the FO command like we did before to move the carbon signals, it's reading the hydrogen NMR parts per million, not the carbon NMR. So remember, hydrogen NMR goes from 0 to 10, where carbon goes 0 to 200. So if I figure out where this TMS is for this carbon NMR and try to fix it, it's going to be way off. So you only set TMS in the proton NMR. All right, now I've pressed, left-clicked, and held. I'm going to set my cursor, my vertical line, horizontal line there. I'm going to type the letter M, minimum peak heights, and I'll see some signals here, right? Now I got to decide, do I like this table or do I like these peak heights? I think I like the table better. If you go to view, you can choose whichever you want. So I'm going to take away peak labels. And I got this peak one. Looks like this one's showing up as a doublet for some reason. Oh, it's the negative one, huh? I'm kidding. Actually, this isn't something I'll teach you guys, but I'm going to phase this for us real quick. It's going to adjust that. So see how that one's a bit off? Oh, fixed. I got to fix both sides. It looks good. And then I zoom back out. Okay, here we go. Oh, there we go. All right, now let me do my minimum peak height again. Click and hold, type M. There we go. I'm just getting the 4 signals I want. I'm gonna go view. Yeah, first one's at 169 parts per million, the carbonyl. And then we got alpha to oxygen here, about 60, 19 and 13 for the other two. TMS is over there. Okay, and then for carbon NMR, it's easier because we don't have to shim. I mean, not shim. We don't have to integrate. You just from carbon NMR, you move on to, zoom in on the area you want, add a text box and print. So I like to always get 200. I'll go from like 200 to a little past 0. Right click in, I'm in zoom currently. Hit enter to get out of zoom, and then I'll do. What's the command for a text box? Does anybody know it? Does anybody know? Yeah, it's no, N-O. And so I'm already in the subroutine. I got to hit A to enter a box. And I hit the same, type in the same thing as I said before. This was the about 95% ethyl acetate and 5% TMS. Click on OK. Put it where I want it. Maybe I want it here this time. Now I'm in the enter notes. I want to get out of that. Got to hit enter to get out of there. Now I'm base level. To print while I'm in carbon NMR, I'm not in the integration subroutine. So I need to do something besides just the letter P to print. I have to hit P and then the letter L. And then that's it. When you're printing a proton NMR, you have to hit P to print, carbon NMR, PL. It's just because in the proton NMR, you're within the integration subroutine when you print. Oh, the printer's looking good. I ran a head cleaner on it. Look at that beauty, right? Oh, she's a beauty. So you know what I'm gonna do? It's a little bit off actually, but good enough. I'm gonna run the proton NMR again and print it again. So I should just do it quickly, watch. So I'm in the carbon there. I'm gonna go NU space H1, enter. ZG, enter. And I'm going to print the proton NMR on the back of this guy. Save some paper. All right, my scan's already done. See how quick this is? I go over to nuts. To bring it into nuts, I type the command A2. There it is. I can zoom in on my main signals. Looking good. Then I can do my text box next. NO add.
New one, 5%. Acetate. Oh, wait, I forgot the TMS. Oh, 95%. 5%. Tetramethylsilane. 95%.
Okay. Move that where I want it. Enter, do I want this box? That's all right. Okay, now I'm going to integrate. I hit enter to get to the base level. Integrates ID. It's got the old cuts from before, and they're pretty good. This one's a little further than I want. What you do when you have the old cuts from the last time you did it, you type the letter C and it'll clear all the cuts. Easy enough, huh? And then I can do 2 clicks on this side, 1 on this side, 2 clicks on this side, 1 on that side, 2 clicks, 1 click. Last time I called this 2, and that was my reference. I can choose one of these to be the reference. I could say, oh, I'm going to click once here, type V, and then I'm going to call this one 3. This is now my reference point, 3 to 2.96 to 1.99. I can call this one the reference too. I can change it whatever I want. If I click once, type V, 3, oh no, not 5, 3, enter. That's the reference, 3 to 3.04 to 2.02. I'll keep that one, doesn't matter really. And now to print, I'm in this integral subroutine, I just hit P. Now it's printing. Okay, so we ran a concentrated sample, ethyl acetate, 95% ethyl acetate. Now we're going to prepare and run a dilute sample. We're going to run about 5% toluene. Next up, we'll take an NMR of toluene. Here's toluene, another clear liquid. Through the structure on there, you can see through the white paper. It's a benzene ring with a methyl. So we'll take an NMR of toluene, but this one we're going to do as a dilute sample, so you get to see what that's like. So remember, with the concentrated sample, we just added a little bit of the pure tetramethylsilane, the 99.9%, this one. Well, actually, I used the smaller. It came from this bottle, but we used a little vial of it, right, TMS. And for a dilute sample, we're going to dilute it with the most popular NMR solvent. Here it is. The most popular NMR solvent is chloroform D, or deuterated chloroform. It's 99.8% isotopically pure, and it also already contains a little TMS for us, 1%. So let me show you what that means. So this solvent is 99.8% deuterated chloroform, CDCl3. Chloroform is the stuff you saw in old movies. You put it on a rag and put it over a person's mouth and make them pass out. We won't be doing that, but so we got that. And so it's got the H2 isotope. This way, we won't have to worry about seeing hydrogen signals in our NMR, because deuterium shows up at a whole nother radio frequency range. All right, and then but it also will have some of the 0.2% of the regular chloroform, CHCl3. We can see that. That does show up at 7.26 parts per million in the proton NMR as a 1 hydrogen singlet, of course. So we can look for that, but there'll be very little of it because it's only 0.2%, and the deuterated doesn't show up. So we have that solvent, but this is actually together, I should really say, this is that combination is just 99% of the solvent. We also have 1% TMS added into this, so we won't have to add the bottle of TMS, so it's already part of it. So let me show you how we're going to do it. We're going to take our toluene NMR tube. It's like the other one we did, but see how it says 100%, 10% toluene, 5% TMS. Well, maybe not 5%, but 10% toluene, about some TMS, and deuterated chloroform mostly, right? Okay, So there's our label, and this was what I made up before, but it's evaporated. It does slowly evaporate out of the cap. So I'm going to open this up and prepare my new sample. Okay, here I go. I'm going to take the NMR tube cap off slowly. Like I said, it kind of gets stuck on there. I don't want to break the tube. There we go, it's off. And then I'm going to get some toluene. And when I open it up and I draw the first amount of toluene out, it might drip a lot. Let's see. Actually, it's not too bad. Toluene's not too volatile. But I'm going to still draw some up and push it back in a few times. Cool down the pipette. And then I'm going to take and I'm going to put just a little bit in there because I want just like about 5%, I said. That's plenty. See it in the bottom of the tube there? Got a little bit of toluene. Oh, you know what I forgot to do? To mark the 4 centimeter high mark for preparing my sample. That's okay, I can do that now. I'll get my ruler, put my sample down to the bottom, and then I'll go to about 4 centimeters, approximately. That's pretty good, about 4 centimeters high. And now I know how much to add my deuterated chloroform with TMS. So here's that deuterated chloroform bottle with TMS. Where's the label? There it is, right? Okay, let me set down my ruler. Open up the bottle. Whoops, lost the cap, that's okay. And now this, I haven't used this solvent yet, or this pipette, so I'm going to draw some up and see if it drips a lot. It's dripping pretty good. I'm not squeezing the bowl, that's just dripping. I'm going to push it out, draw some up, push it out, do that a few times. Cool down the pipette. And then I'm going to slowly start adding that deuterated chloroform with TMS to the line I made. Keep going. Oh, I went a little over, but that's okay. And there I have it. I just got to cap it, mix it. Okay, this is ready to go. I'm going to put the label back on it right away so I don't confuse it with other samples. And we'll go run it in the NMR. All right, what's the first thing we want to do before we run our sample? Predict the spectrum. So here we go. Remember, we're going to have, our sample is going to be about 90, what did I say? Maybe, let's say 94% deuterated chloroform, our solvent. And that's approximate. There is going to be, I don't know, maybe 0.01% chloroform, the non-isotopically pure deuterated chloroform solvent. Then maybe 1% about TMS, and about 5% toluene. Okay, so what are we expecting? From the deuterated chloroform, sorry. Nada, nothing. Shouldn't see any signals for that. From the TMS, of course, we're going to see our signal that we're going to set to 0. So for the hydrogen NMR, it should be a 12 hydrogen singlet at about 0 parts per million. Easy, right? Okay. Now for our sample. The TMS, the toluene is going to be an interesting one. We've gone over this coupling. This one's got some challenging bond counting involved. So it turns out this methyl up here is a 3 hydrogen singlet. It doesn't couple to this hydrogen because it's through one CH bond, a long single bond, and only like a half a pi bond there because there's resonance, and then another. So it's 1, 2, 3, 4 bonds away. It only goes through half a pi bond too far. It's going to be a singlet. It winds up being at about, showing up at about 2 parts per million because it's being deshielded by the aromatic ring. We'll talk more about that later. Next up, I got these 2 hydrogens are equivalent, and they make a 2 hydrogen triplet because it can definitely couple this neighbor. 1, 2, 3. That's 3 bonds away. It can couple this one too. 1, 2, 3, 4, because it goes through 2 half pi bonds, like it went through a whole full double bond, and that shows up at about 7.5 parts per million. Got it. Next up, these two. Oh, by the way, this is the two hydrogen. This is a one hydrogen triplet. That's a one hydrogen triplet. They're equivalent, so they make a two hydrogen triplet. All right, here we go. Another two hydrogen. How many neighbors do they see? Definitely sees this neighbor because that's 1, 2, 3 bonds away. Sees this neighbor too. 1, 2, 3, and that's it. So those neighbors are not equivalent, so it's a triplet. Around there, right? And then this finally, it shows up as a one hydrogen signal. And how many neighbors does it have? It definitely has this neighbor, 1, 2, 3 bonds. Definitely has that neighbor, 1, 2, 3. Those are two neighbors that are equivalent. Does it get to this one? 1, 2, 3, 4. Oh, 1 through 2 medium length partial pi bonds. Yep, and that one too. So it's got 1, 2, 3, 4 neighbors. So it's a penta. All right, and then let's do the carbon NMR since we're here. So the carbon NMR, the carbon NMR could show your carbon from the solvent deuterate-chloroform, but you usually don't see it unless you have stronger, more powerful NMRs. It shows up as a triplet because the deuterium has 3 spin states. It couples it differently than a hydrogen, and it doesn't get decoupled. There's proton decoupling, like H1 isotope decoupling, but not deuterium decoupling. But let's not worry about that. Let's focus on this toluene. So the toluene here, it's going to have 1 signal, 2 signals, 3, 4, 5 signals. And where are they going to show up? This one is going to show up at about, I'm going to guess 25 parts per million. It gets deshielded by the benzene ring. When you're directly attached to a benzene ring, you show up kind of in the same area as alpha to a carbonyl. And then this one, and this one, and this one, and this one, they're all going to show up between like 160 and 100 parts per million, where aromatic and alkene signals show up. This one we might be able to identify this one because it has no hydrogens attached to it. And when you have no hydrogens, you're normally a very short signal. So we'll look for the shortest signal, and it might be that one there. Okay, let's run it. Other sample already in there. The ethyl acetate we ran, so I got to eject that first. How do I do it again? I need to hold this over there to catch it as it pops up, and then I have to hit the eject button. So I don't know how I'm going to do this and hold the camera, but I think I can do it. I'm holding that there. I'm going to come over with my pinky. Can you see my pinky? I hit the eject, I'm pressing it, and I got it over here. There it is, yep. There's my sample. And so now I just need to remove the spinner, but I don't want to touch it because I don't want to get my greasy fingers on there. So I'm going to remove it by holding the spinner with the chem wipe like that. See how I'm not touching the spinner? And I just slide the tube out and set that spinner down there for a sec. There it is. And here's my ethyl acetate. I'll put its label back on so as not to confuse it with other samples. I'll come over and I'll find my toluene. Here it is. And I'm going to put this in the spinner as well. Okay, here we go. Grab my spinner, not touching it. And remember, I'm putting the NMR tube into the thicker end, like that. And slide it down a little bit, and then I'm going to adjust the height with our gauge here. I just slowly press that down there until it stops. That's the height that should be good. And then I bring it over to the metal tube here, and then when I first set it in there, it floats. Pretty cool, huh? And then I come over here and I hit the power off, so it'll drop down in. Let's see. Drops down in, and then I hit the power on, and I look down the tube and hope to see it start spinning. Let's see. I'm going to try to get a better angle on it this time. A better view of it for you guys. Can you see it? It's pretty dark down there. Okay, I'm going to hit the power on. Yeah, I think it started spinning. See it? It's kind of hard to see. The resolution's not great. But in person, I'm looking at it, and yes, it is definitely spinning. Okay, let's run it. Looking good. All right, we're back at the computer here. We have our dilute toluene in there spinning. First thing we want to do is a proton NMR. So I come to AII PNMR software. Make sure it's in the proton setting, which it is. It says H1 there. So how do I start my scan? ZG, enter, enter. I just wait for the scan to go. You're going to see this is going to need shimming because I went from a concentrated sample to a dilute sample. One scan complete. Oh, look at, see how small the FID is? This is because it's a dilute sample and our receiver gain's only at 1 because it was set for a concentrated sample. That's okay. We're going to still see what we got. So I'm in AII PNMR. I'm going to go over to NUTS right here, the NUTS software. This has got the old spectrum up there, and it's an integral subroutine. I'm going to get out of that by hitting enter, back base level. And then how do I bring it over from NUTS? Oh, I remember the command, the letter A and the number 2, and there it is. Actually, it doesn't look too bad. You can see there's our TMS. Not too bad. And then here's the methyl off the benzene ring, looking good. And then all of our aromatic signals for toluene, they all overlap. I know it looks like a singlet, but it's not. This is the 2 hydrogen triplet, and the other 2 hydrogen triplet, and the 1 hydrogen pentat, all just on top of each other. If you have a stronger NMR than ours, you could start to see resolution for these. But that's what that is. And you know what? It doesn't look like we need to shim. But I'm going to shim anyways because I want the practice. I want to show you guys how to do it. So to shim, and oh, I can set the TMS to 0 now or shim. It doesn't matter what I do first. I'm going to shim first. So I'll come over here to the shim, to AII PNMR, and I'm going to type the command for shimming. It's just shim. Watch as I type it out here. SHIM. I hit enter, and then it asks for the relaxation delay. 2 seconds is a good starting point. It's set to it's set to 2 as well. And then I hit enter, and it's going to start adjusting the little electromagnets around the sample. So our sample is in the NMR, and it has a main strong magnetic field applied to it, and then little electromagnets around it are being tweaked so that the magnetic field strength is the same on the bottom, the middle, the top, and you get nice signals. So it's currently shimming like electromagnets C and Y, and it won't take too long. We might see some of the adjustments here. Oh yeah, look, see the receiver gain was 1. It was set for a concentrated sample, but now it's 12. It's like a hearing aid. It got turned up because this dilute toluene is not causing strong signals. All right, it's done. So now we will rerun our proton NMR. I'll hit ZG, enter, enter. Scan is complete. See the bigger FID now? Receiver gain went back to 12. It went back to 5. It was at 1 to begin with, and we saw it go to 12 and then back to 5. Relaxation delay we set to 2 seconds, but now it decided 3 was best. So anyways, let's bring it over to NUTS. We're in NUTS now. Bring it over, it's A2. Looks about the same, but it should be a little tighter. Yeah, it looks a little better, huh? A little sharper singlets. Yeah, looks good, really good. All right, now our TMS is still off. So I'm gonna click and hold in that horizontal line there. I'm gonna make it so that the TMS is poked through it. So I type M, and it looks like my TMS is at 0.271. So I come over to AII, frequency offset, FO, hit enter. So I'm at 0.271. I believe that's what it was. Let me double check. Yeah, it's positive 0.271. And then that's where it currently is, the TMS. I hit OK, and then where do I want it? I want it at 0. OK. And then I rescan it to get new data and bring it over. ZG, enter, enter. We'll rescan. All right, it's done. Now I go over to NUTS, and to bring this new one over, I type A2 and watch carefully. TMS is now at 0. I can zoom in. It's looking really good. I can do the minimum peak height again. Click and hold, touch M. Yeah, it's at, ooh, look at that one, 0.001. Awesome. Okay, so I'm gonna get into my zoom subroutine, right click out. I'm gonna drag over the entire area there, the area that I wanna have my signals on, and then right click in. Now I'm in the zoom subroutine, I gotta get out of that. Next thing is the text box. I still have my old text box. That's kind of nice. I'm just gonna modify that. So if I type NO, that's no, the command, I can double click this. Nope, that's not what I wanted to do. I hit enter, get out of that. I type NO and right click this, and then I can just change this up here. So our sample is, what did I say? 94% about? I'll say approximately. 94% CDCL3. That L should be lowercase, huh? And about 1% TMS and about 5% Toluene. Too many N's. I think that's good, huh? Toluene, good. Okay, hit OK, and there it is. Let me move it over a little bit. Okay, and then I'm still in the zoom, the enter notes subroutine. I'm gonna hit enter and get out of that. Now I want to integrate. How do I integrate? ID. And see how it's weird? It's all cut up here. This was the cuts we did for our very concentrated ethyl acetate. We don't want these. We want to make new cuts. So how do we get new cuts? We type the letter C, and it clears all those old cuts. And you can use that like if you make a mistake. Let's say I'm like cutting here and I go, oh, whoops. Oh, no, I don't want that. Oh, no. You want to just start fresh? Type the letter C. Boom. So how do I do my cuts? 2 clicks on one side, 1 click on the other. 2 clicks on one side, 1 click on the other. 2 clicks on one click. Wait a minute. Do I want to integrate TMS? Nah. If you do make it a mistake, if you type the letter L, it'll delete the very last one you did. So look, L. And if I hit L again, oh, it's this one. Oh, I want that one though. So 2 clicks, 1 click. Got it. Okay, this is saying 2.73, but I know this is the methyl. This is my 3 hydrogen singlet, right? I'm gonna set that to 3. And then the aromatics, I'm supposed to have a 2, 2, and 1. They're all overlapping. So 2 plus 2 plus 1 is 5. So I should have a 3 to 5. Let's set this guy to 3. I click once, see how it's red, and I make sure the red is in its integral. I type the letter V, 3 for that, and there's 3. Hit OK, and there we go. Oh, look at that, so good. 3 to 5.07. Love it. And now when I want to print and I'm in the integral subroutine, I hit the letter P, and it's going to send it right to the printer automatically. While it's sending it to the printer, I can be super efficient. I can just go over here and start doing my carbon NMR. I type NU space, see down here, C13, enter. Now I'm in the carbon 13 setting. I type ZG, enter, enter, and now I'm running my carbon NMR. My proton NMR came out pretty good. It's not printing exactly great, but that's all right. It's gonna get better. As I, oh wow, the whole signal's missing. It's not good. I need to do another head cleaner. Yeah. And then look at that. I've already got 3 of 12 scans, and I could have done more than 12 scans, and you'll see I probably should have. So for our carbon NMR, we are expecting 1, 2, 3, 4, 5 total carbon signals, 4 in the aromatic region and 1 not. Let's see what we get. We probably won't get all those because our sample is dilute, and this is a carbon 13 spectrum where carbon 13 is not very abundant. So we're almost there, about halfway already, over halfway, huh? 8 out of 12 complete. We'll see that soon. All right, it's done. Click OK. And then I go back to my nuts program. I'm in the integral subroutine. I hit enter to get out of that. How do I bring in the carbon scans? I have to hold Control and F3. And then this comes up. I named it the default name, so I just say open. Line broadening, it's always 0.5. Okay, and here's our spectrum. Woo, it's looking pretty crazy, huh? Lot of noise. I'm gonna bring this down with my mouse wheel. And then I'm gonna click and hold. I'm gonna type M, so it's only showing signals above that horizontal line. So if I go like this, I can see, oh, M. Yeah, I'm just seeing that 1 there. If I have my horizontal line in here, that's when it gets all, so I want to get rid of that. So let me raise this up a little bit. Maybe I'm seeing a few of my aromatics, not that many, huh? Because this sample's dilute, and that's normal for our NMR. This might be the methyl, it's hard to tell. Let's try running it again, but this time we'll run it with more scans than 12 and see if that helps. Carbon signal didn't come out great. What I'm going to do is I'm going to try increasing the number of scans. And if you look over here, you'll see its default value is number of scans 12 out of 12, 12 scans basically. So, and the command for that is easy enough. It's just N, S, space, and then you enter the value you want. Let's try a double. Let's try 24. So NS24, see it there. And then when I hit enter, I'm hitting enter now. It will now say it's 12 out of 24. It's telling us it's going to do 24 scans. So let's restart it. Do a ZG, enter, enter, ZG, enter, save the default name, enter. And we'll wait for the 24 scans and bring that into nuts and see if it looks better. I'm not at the 24 scans yet, but I could still actually go and look and see what I got. So if I go over to nuts and I hit, let me get rid of this meta object first. But if I hit Control F3, enter, 0.5, enter, it'll bring over, however many scans on that. So that might have been, by the time I got to this, I might have been about 20 scans. And if I click and hold and type M, won't look quite so crazy. It is looking better. That looks better than before a little bit, huh? Than the 12 scans. And this was, it might even get a little better. So let's see. Yeah, the 24 scans is done. So let's bring over the 24 and see how it looks. So again, it's Control F3. I'll show you on the keyboard here this time. Control, and then I tap F3. There we go, and it brings over this dialog box. So I say OK to choose that one. 0.5, 0.5, enter. Yeah, this looks better. I'll tell you what I'll do. I'll print this, I'll save this spectrum, and then I'll run it again. Let's try like a triple, so we'll go 36, see what happens. Okay, so here I go. I'm going to make it 36 again. You go N, S space 36, hit enter, ZG, enter, enter, and let that go. While it's going, I'm going to process this last spectrum we took, the 24 scans. So I'm going to do the minimum peak height thing first. And then I'm going to do that meta object you saw earlier. So what I'm going to do is I'm going to get into zoom by double clicking, drag a box over my peaks, right click, raise them up a little bit, get them to where I like them. This one looks like it might be something too, huh? Zoom in just on these main ones here. And then I hit enter to get out of zoom and MO meta object. And I hit add. And then it shouldn't be asking me about the printer, it's a type, it's like a glitch, but let's ignore that. Now this is a little bit of a zoom in of the area that we have on the screen. And then what I do is I exit MO and I go back out to the entire spectrum. So that meant double click anywhere, right click, and now I got the entire spectrum. I'm going to go from like a little past 200 to 0, right click. And now my meta object's pretty huge right now, but I can go back into meta object, grab it, move it around, shrink it around, whatever I want to do. This looks pretty good. I like it. Seeing 3 aromatic signals. And then I could decide between having these peaks or the table. I think I'm going to keep just the table. So let's go view. Yeah, I like that. I got the peak labels there and the table. And then I'll add a text box as always. What's the command? No, N-O-A. And I'm going to type in the samples information, my name, and date. And I'll put in that as 24 scans. Alright, my 36 scans are complete. See it here, 36 out of 36. So let's bring it over to nuts. Go into nuts. I got the meta object from before. I'll go into meta objects again, M-O, and then D to delete it, and then enter to exit out of that. And then to bring in the new one, Control F3, I saved it as that default name, so select that, and then 0.5, enter. Oh yeah, it got better, 36, huh? Well, look at that. I think we're seeing the methyl here too, huh? So I'm gonna hold this and type M. There we go, looking good. Let's do a meta object on this one again too. Zoom in on it. Right click it, yep, looking better. MOA, add that. I don't know why it's asking me about the printer setup. Ignore it. Zoom back. Double click anywhere, zoom back out. Okay. And then I'll go MO again to get this where I want to get right there. That was pretty good, maybe a little bigger. Not bad. Oh, a little higher. I like it. Exit MO. And look, I got the TMS signal too. I'm going to get rid of these peak labels. There we go. Not the TMS, I'm sorry. I have the methyl signal, it looks like. Off of the toluene. Okay, now I'll type a text box and save it and share it with you guys. So I switched from a dilute sample, the dilute toluene, back to the concentrated ethyl acetate, and you see the baseline, how it's kind of weird looking? That's a sign that it needs to be shimmed, and that's totally common for when you switch from a dilute sample to a concentrated sample, or from dilute to concentrated or concentrated to dilute. But the peaks are pretty sharp. It's doable actually, but yeah, when I see that, I usually shim it. Okay, I'm gonna shim it. I typed shim already. Oh, and next I'll do the enter, and then it's going to ask me relaxation delay. I'm going to put 2 seconds, hit OK. And watch as the receiver gain is going to be adjusted. It's all red because it was, I just put in a concentrated sample, so it went down. The receiver gain got adjusted because the concentrated sample wants to turn down that gain so it doesn't give you such huge signals. And it's shimming on electromagnets C and Y are being adjusted. See it's pulsing through. It'll take a little while, and then we'll be able to run our proton NMR again on this ethyl acetate, and it'll look a lot better. Okay, so here's a before and after of the shimming. So before we shimmed, the FID was large because we went from a dilute sample to a concentrated one, so the detector was turned on to be too sensitive. And then when we got the spectrum, it had this wavy baseline here that suggests it needs to be shimmed. Another thing that you could tell it needs to be shimmed, if the TMS was not a singlet, this time it was a singlet, but if it's like a doublet or something. Then after we shimmed, you could see the FID got a lot smaller, more reasonable, and the receiver gain's way down to 2 now. And the spectrum itself, look at that, nice flat baseline. And I adjusted TMS to 0 as well. So yeah, a couple things you'll look for is if the baseline's wavy, or if you're seeing like TMS is a doublet, or if you're expecting this to be a single and it's a doublet or something. That tells you just shim it.